Hey guys, here's your notes on translated ellipses. All you have to do today is the notes. And Monday, we will finish the math lab. Some of you will be working ahead though, because I'm going to post the math lab video later so that you can work ahead if you want, and then you can take Monday off while you figure everything out. Okay, so you could copy these down if you want. They're posted in the Google Classroom. Basically, it's stuff I would write down. These notes here are more confusing until you actually do an example. You may or may not want to write those 3 things down. And then here is the example, which I will actually do for you right now. So you can either do that with me or you can just copy it down from the notes. Some of you like to have the big formula things written down. This is what you could write down if you want to pause the video for that. Oh, the picture can't be shown. Wonder why. I see it right there, clear as can be. Let's see if I say present. I'll show you the no, it's not showing me the pictures. Jerks. It's okay, just for a second. This is the, that's not it. These are the things you'll really need to know right here. And if you can see the picture here, I don't know if I could even make it zoom in. Like that says HK, that says H plus CK, H plus AK, H minus CK, and that says H minus AK. And then there's this one as well. And then it goes in the up or down direction. You can pause it and write this down if you want. I don't like this, but some people do. And it says HK, and then it says HK plus C, HK plus A, HK minus C, and HK minus A. Okay, so what we are going to do is, I'm really just going to do this one example here because it's going to talk about everything. Basically, today's thing is the center is going to be moved around. So if the center is moved around and you have your A and your B, you have to count everything from the center. So it's not going to have like the opposite qualities that some of the ones did yesterday that were really nice because they had symmetry. So you'll actually have to count to find the points. Or you can add and subtract from one of the coordinates of the center. You'll see that in a minute. Still the same things are true though. HK is always the center. Comes from the comes from the x parenthesis, from the y parenthesis. A squared is the biggest number. It tells you the direction. So a squared here is under x, so it's going in this x direction. And if it's under the y, it goes up or down in the y direction. The focus comes from the c. A squared minus b squared equals c squared. And remember, we're thinking about Stewie from Family Guy, and his eyes would be the focus. Okay, so all we're going to do is this example here. Let me cover some of this up. And it's going to show you how to change it to the way we want, and then how we'll use the graph to answer all the questions, okay? So, all right, first thing you need to do is make it look the way we like it to look. It says it's an ellipse, which is nice, but all of these are going to equal 1 and have fractions. And right now it does not equal 1, and I do not have fractions. So what we're going to do is we're going to get the x squared together with his friend, just rearrange everything, leave a little space, get the y squared together with his friend, leave a little space, and we're going to move that constant to the other side. And that's where we're going to start. Now, this side's ready to go. It looks like yesterday's, but this does not. That 4 in front is a problem. You have to divide all the x stuff by that 4 because you cannot complete the square with the 4 there. So it's going to be an x squared plus 6x. This one I said is ready to go. Now we can find the magic number. The magic number is half of 6, which is 3. 3 squared is 9. But when I put a plus 9 here, I didn't really put a plus 9 here. I put 4 times 9 there. So by putting a 9 there, I actually added 36 to that side. And to keep it equal, you have to add 36 to this side as well. This one, I don't have to divide anything because there's nothing in front of the y, but if there was, I would. I can go straight to finding the magic number. Half of 2 is 1. 1 squared is 1. I will add 1 to both of these. And now I can write it the way I need it. There's a 4. This parenthesis is an x plus 3 squared. That's why I put it there. This one does not have a number in front, so it's just right to the parentheses, y minus 1 squared. And then you take those numbers and you add them together, and you get 16. This almost looks right, except ellipses are supposed to equal 1. So now you divide everything by the 16 to make it equal 1, and you simplify this fraction right here. And the graph I'm going to be looking at is x plus 3 squared over 4, because 4 over 16 is 1/4. The second one is fine. No fraction to simplify there, equals 1, which is what I needed to do. So that is the steps I said might be a little confusing as far as completing the square goes. But once you get it looking like this, we can go to the graphing and finding the points. You're going to want to sketch while you find the points. It's going to help you a lot. Okay, so first thing I need to do is ask myself, what is the center? I always ask myself that first. Center comes from the x parentheses, the y parentheses, change the sign. The center is -3, +1. I'm going to go ahead and graph that. Ooh, sorry. This is not very, I'm kind of crooked today. Okay, that's my center. Now I need to figure out what direction things are going. A squared is always the biggest number, and it is 16, which means a is the square root of 16 or 4, and it is in the y direction. So it's going to go up or down. So I'm going to count 4 up or down from my center. Now look, I'm still at -3. So the one that's changing is this. I'm taking 1 plus 4 and 1 minus 4. So 1 plus 4 would be here, and 1 minus 4 would be at -3. And those are the vertices. The vertices are the big ones on the end of that major axis. And that's -3. What did I do? I took 1 plus 4, or you could count here, and that's 5. And -3, 1 minus 4 was -3. Those are the vertices. That's from the A. Then you have b squared, which tells you the co-vertices is 4. So b equals 2, and that's in the x direction. So there's a vertex, excuse me. There's a co-vertex. They don't usually ask me to tell those on MathLab that I've seen yet. So I'm going to go ahead and draw it. There's Stewie's head. There's my ellipse. It's kind of good. Oh, kind of messed that up. Okay. Now I need to put the focus still. Don't forget. So it's a squared minus b squared equals c squared. And this is where kids get a little bit stuck. So 16 minus 4 equals c squared. 12 is c squared. Square root both sides. So that's 4 times 3. And that's going to be 2 square root of 3. Okay. Now, the dots aren't super important here. I mean, I can. 2 square root of 3 is about 3.5. If that helps me count, that's fine. From here, 3.5 will be about here and here, okay? But I need to know the exact order pairs. So where would those dots be? Okay, well, what stays the same? One thing always stays the same on the center, still at -3. And then what did I do? I went from my center 1, and I went up 2 root 3, and I went down 2 root 3. So I'm at 1, up 2 root 3, just add it to it, and then down 2 root 3. Okay, so this is an example of how to use this equation and how to move it to that equation and use the graph to help you with all the stuff. Okay, that's all I have for today. Again, I'm going to make the MathLab video so you can work ahead if you'd like, but that is completely up to you.